Hey everyone.
Hey
So
everyone.
yeah, Ty, you want to take it off?
Sure. Hi everyone. Thanks for joining today's session, The Magic Behind AI and ML. My name is Ty and I'm joined with my coworker here, Michael. We're both data scientists at Cubesmart, a self-storage company in the United States. And today we plan to talk about what is AI, artificial intelligence, and ML, or machine learning. What skills are needed for them, and finally, our advice for those who may want to pursue this field as a career. So let's start with what is AI and ML and what it means. So the artificial intelligence and machine learning are basically two terms that are thrown around a lot. It's pretty hot. Nowadays, you basically hear it from here and anywhere you go. I will start with the word intelligence. If I were to ask everyone here to really quick define what is intelligence, I'm sure we would get like 1,000 or maybe millions different responses depending how many people we have in this room now. But probably I would guess the most of the answers or definitions would describe or at least allude to describe that this is the process of acquiring information around us and then applying this information and knowledge we just get to make some decisions in some way. It could be some recommendations, it could be something else. So when we hear the artificial intelligence, first it is intelligence. It's basically referring to the similar process, but artificial. That means it's basically specifically found in the computer systems or machine systems. And so an intelligent computer system will receive some type of input information, and then that will result in some type of applications. So machine learning, on the other hand, or ML, is a major subset of artificial intelligence. So this refers to when the computer system acquires the historic information, or we call it data in another word, and then effectively learns how to behave in future scenarios. So this ability to basically teach a computer how to learn from a large amounts of historical data is what we have been seeing that has been driving for the most recent AI boom in the past probably 10 or 20 years. So examples of AIs are just everywhere. It's all around us. So I suspect no one's in this conference call could even go without day without interacting with any sort of AI system here. So we list some examples here in the slides. So like self-driving cars is a kind of a cool concept. So self-driving cars learn. We have a system behind the scenes learn from the historical driving footage. It could be tons of like images on the road. So it basically learns the knowledge of when to stop, which lane to stay on, how fast you go, or what is the current traffic light. So it basically learns a lot. Basically, it has to make decisions that the same decisions we drive every day. Another thing could be a virtual assistant on our phones or our computers. We can give some instructions to them and can do things for us. So the virtual assistant could recognize the words out of our voice. And also, in addition to that, it has to understand our language, what is the logic behind it in order to do things. And we also, pretty common, we have wearable devices. I have one here, just a watch here. It can monitor and all kind of data, like movement data, health data. And sometimes it's cool, it can identify the kind of workout type, whether I'm running or I'm just walking, or even on the specific workout machines there. Those are kind of cool things, but behind the scenes, they're all kind of artificial intelligence. And also, we are kind of in a social media era, so we're always wondering what is the next video in our feed, and sometimes we see some personalized ads that just gets us. So all things has happened with the help of artificial intelligence and machine learnings. So as we mentioned before, we're from Cubesmart. So what we do at Cubesmart as a data scientist basically falls the same category. It's just our domain is kind of happens to be the self-storage business, the specific business. So we basically focus on creating the AI and ML systems that help solve business problems and provide business recommendations or decisions, strategic thinking every day. I mean, these all kinds of different applications look so different, but surprisingly, they actually share the same foundation. So I think next I will hand over to Michael. Michael will reveal the secret sauce behind the scenes and what is this foundation and what kind of skills we need to build all these kind of intelligent system. Michael?
Yeah, thanks, Tai. So yeah, like Ty said, we all know a lot of different applications of AI around us, right? He mentioned we can't go a day without using some interface that leverages AI. But at the core, Ty and I talked about it, and there are really three core subjects that data scientists and people in the AI and ML space focus on. So those are math, computer science, and critical thinking. So I just quickly want to preface that this doesn't mean ignore every other field if you want to work in AI. Just like any career, you have to be well-rounded. It's super important, no matter what you end up doing. If you need to communicate and explain your work, which is pretty much universal for every position, every career path, that requires language and communication skills. So that's just one example, but if it's just a quick disclaimer. I don't want people walking away saying, I only need to learn math, computer science, and critical thinking, and I'm good to go. No, definitely be well-rounded, but there are really three core subjects in AI and ML, and those are math, computer science, and critical thinking. In order to build artificial intelligence systems, those are the three fields. So they're each really important, and what's interesting about them is they lean on each other. So if you think of it as like a three-legged table in a sense, without one, the AI and ML systems that we have, they fall apart. So we'll go through each one of them, and we'll start with math. So math is heavily used, and there are kind of three areas of math that are most frequently used, but it's not exclusive. So those are statistics, calculus, and linear algebra. So depending on what your AI system does, whatever you build in your future, you may need other areas of math, but you'll always need these three. So some examples of AI that we already talked about, we can say, even though we don't work in that domain, but we know that they are all using stats, linear algebra, and calculus. And what's funny is I remember when I would sit in my high school math classes, I used to sit there and be like, am I ever going to use this? I don't really see myself in the future using this. But the irony is now I use it every day. It really is the backbone, and I can't stress that enough, that math is the backbone of AI and ML. So what's really cool about math, and like maybe that sounds like an oxymoron to some of you, but what is really cool is that it does unveil sort of the magic behind how these algorithms and models work. For instance, like your social media, Ty said, how does it know what content to show you when you're scrolling? It seems like every video that pops up is exactly what you want to watch next. Or, virtual assistants like Siri or Alexa, when you speak to it, how does it know what we're saying, right? Like it's an interesting process that seems weird and sort of mystified and magical, but really it's just a series of math equations that are working together. And once you learn the math, the AI systems that once seemed magical and sort of confusing, they really become like quite tangible, and you'd be able to start explaining and understanding how the AI systems work. But like I said, these are three pegs that work together. They can't stand alone, and so the computer science is just as important. And computer science, if math explains how the AI works, then computer science is what's needed to actually tell the computer what to do, right? So artificial intelligence is basically intelligent processes that live within computers, but a computer isn't just born with artificial intelligence. We have to instruct it. So without computers, we would never really be able to carry out these models and AI algorithms. Just like a quick, simple example. If I gave everyone here 1 million pieces of paper, and on each page was filled with data, like to the top to the bottom of the page, it just was just filled with numbers, and each number was sort of identified. It just was a tons and tons of data. And then if I asked you, okay, with your stack of 1 million papers, I want you to study each page, as in I want you to flip through every single page and learn something. After you flip through, tell me what you've learned. That would be totally unreasonable. Like no one could do that. It would, first of all, it would take impossibly long for you to even just flip through 1 million pages. But then to actually learn something from those 1 million pages, you would need to see probably each page maybe 2 times, maybe 3 times or more. Whenever you study for a test, you probably, you go over your material, or maybe you don't study, but if you do, but you go over your material multiple times. It's an absolute necessity for us to learn. But that's where computer science comes in with a programming language. So it doesn't matter what programming language, but as long as you're able to communicate, and that's what programming languages allow us as humans to do, we can communicate with our computers and instruct them to do exactly that. They can flip through massive amounts of data in an extremely efficient and quick amount of time. So by using this computer science, we're able to give this instruction. And by giving that instruction, that's building an AI system. So if the math can explain how AI can work, computer science allows us to actually build AI. So we can communicate with our computer and say, hey, we have all of these math theories and all of these math equations. We also have all of this information. We want to combine it. We want to make something happen with it. And so that's where computer science really plays a critical role. And finally, the third field, it's not so much a classroom field. It's something that you develop over time, but it's absolutely a skill you can work on. It's critical thinking. So, like I said, math and computer science explain how AI works and how AI is built and developed. Critical thinking is why AI gets developed. Being able to visualize a solution to a problem, it's the only way AI systems would ever get built. So if you think like 10 years ago, or I don't know if everyone here had phones 10 years ago, but if 10 years ago, our phones, you had to type in a password. You needed or computers, you needed some password to unlock that device. But now we can use our face, and you still have the option to type in your password, but we can use our face, and it's really convenient. It's pretty cool. It's sort of mysterious. But so that whole unlocking process, someone over the last 10 years, someone said, hey, like, how do we really ensure that the person unlocking this device is who they say they are, right? Because anybody can type in someone else's password. So someone thought, like, well, if we could see the person, then that would actually ensure it. And there wasn't necessarily, these facial recognition math problems that were already out there. Someone had to visualize it and say, hey, I'm going to design a system. I'm going to put together kind of the computer science, and I'm going to put together the math that's required for it. And that decision to pursue and create that solution that uses facial recognition, it took an extreme amount of critical thinking. It never existed before. It wasn't something that people, thought of or had. But yeah, someone had to come up with that idea and make it happen. And so that type of critical thinking it's constantly pushing the boundaries of what AI and ML can achieve. So it's equally as important. Like I said, without critical thinking, nothing gets done. Nothing actually happens. So those are kind of the 3 main subjects. But what does that really mean for you? Like, how do you all prepare for your future in AI and ML? And so that's kind of what we'll talk about next is the preparing for your future. So unfortunately, it's a pretty loaded question, right? Like, how does anyone prepare for their future? There's probably a million things we all need to do. So the first thing is, remember, there's no one way. And as Tai and I will explain later, we have different backgrounds, and we ended up both as data scientists. We sit next to each other. We work on the same problems, but we didn't take the same exact path. So that's the number one thing is, if someone tells you there's only one way to become a data scientist, that's absolutely not true. But like we mentioned, there are kind of those 3 core subjects. The beauty about building AI, though, and intelligent systems is that every industry, every domain has a need for them, right? You can build AI. That Tai and I build AI and ML systems for our company Cubesmart, right? And we work in real estate. But someone could do it for self-driving cars, just as someone else does it for the Siri and Alexa. That's a specific domain of AI. And because every industry has a need for it, the best advice we can give is for you to find out, what are you interested in? What do you enjoy learning? Because sure enough, there is an AI need for those fields. And as you hone in and figure out, okay, I really like maybe biology, or I really like real estate, whatever it is, you'll gravitate towards that field. And then what we would advise is, once you know that and you can focus on the field, the thing that you like, you can add in those 3 other skill sets that we talked about. So becoming an expert in your domain, it's really invaluable. So if your domain is say natural sciences or life sciences, you would learn the ins and outs of biology and organic chemistry, or whatever it is, whatever you like. And you'll understand the problems that your field faces at a much higher level than, say, going a different path, right? If you want to work in life science AI, then focus on life science. There's no reason not to. But then once you learn and become an expert within your domain, you can complement that expertise with math, with computer science, with critical thinking, and you'll be extremely successful in creating AI solutions. So again, focusing on your domain, becoming an expert, and then complementing your expertise with those skills, we think is a really good recipe for success. So that's what we would kind of call the magic behind AI and ML. But again, to reiterate, there's no one way. I'll tell my story, and then Tai can share his. After high school, I went to college and studied financial economics. So that's sort of the domain I work in now. And after college, I ended up working as an analyst in the business intelligence department. So I really focused on that domain, and I felt that was really helpful. And then I realized I sort of wanted to move into the data science and the AI and ML space. And the issue was I had no computer science background, right? I understand the business problems, but I didn't really have the comp sci or those other skills that we talked about that are necessary for data science. So I went back to school and I got my master's in computer science and data science. And you guys are all lucky enough, and what this conference is what's so special about it is it's informing people of data science as a path, before you find out, oh, I want to go back to grad school. So you don't have to go to grad school. You probably you can if you want to. Again, like I said, there's no one way. So if you want to work in AI and ML, it's great to focus on your domain and really focus on those skills as well to complement your domain expertise. But anyway, that's just my path, and Tai has a different path. I don't know, Tai, if you wanna share yours.
Sure. So unlike Michael, I was majored in math back in college. So I first learned all those math techniques back in college, and then along the way during the course of 4 years in college, I realized that there were a lot of interesting real world problems to work on. Not only just theoretical math, they're beautiful too, but I want to focus more on the real world business impact projects that can affect the day-to-day life. So that's why I decided to shift a little bit and then get my master's in data science. So that's and then landed a job here at Cubesmart, where I can finally marry the math I learned back in college and some data science, computer programming, statistics in the grad school, and finally, the business question we're dealing with every day here at Cubesmart together to to kind of grow as a data scientist. So yeah, as Michael mentioned, that there's maybe a million ways, and there are different kind of AI system. For example, the example we gave before, like those virtual assistant, it probably requires many linguistic knowledge that we probably don't have yet, and those those wearable devices. They might require some, biology or maybe even medical knowledge. So every industry probably has their own, specific domain knowledge. So that is actually a core of all those creative ideas. And with that, as helped with the math, computer science, and the critical thinking, I think we can just create different solutions in different industries to really, help us to get a better future. And so I think that's kind of my story and my take on this.
Thank you. But yeah, so if anybody has any questions, I'm going to stop sharing my screen and then I'll pull this over. But if anyone has any questions, Ty and I would be more than happy to answer. If not, I guess our time's up anyway. We ran a little over. Sorry about that. But yeah. Okay. All right. Well, thank you everyone so much. It was a pleasure sharing our experiences and parting, what advice that we have and we can give. And yeah, we hope that it was helpful for you guys and you guys are able to. Oh, Donovan had a question. Sorry about that. Oh, question from a rising third grader. What is an algorithm? Oh, that is a great question. Ty, do you want to handle it or you want me to?
Go for it.
Okay. So an algorithm is, it's one of those things that people say a lot, but you can think of it as you take one thing and then you put it in another, and that middle thing is an algorithm, right? It might change that. It might alter it slightly, and then that first thing that had gone in, it's been changed, it now comes out and it's something new, it's something different. So if you think about, let's say a good analogy might be like cooking, right? If you're baking cookies, you need a recipe. So you need, cookie dough, whatever goes into the ingredients, maybe eggs, maybe some flour. I'll be honest, I have no idea how to make cookies, but let's just say you have the recipe and then you put that into the oven. And then when you take it out of the oven, you now have a cookie, right? But the algorithm was you take all of these first ingredients like milk, eggs, whatever, flour, and then it goes through an algorithm and comes out as a cookie. Yeah, step-by-step instructions to tell what a computer to do. That's sort of what algorithms are, in the sense of I'm telling the computer to make an algorithm. But an algorithm really can be applied in anything. It's just the transformation process. Yeah. So hopefully that was helpful. Yeah. Any other questions? Okay. Well, thank you very much. Again, we hope it was helpful, and best of luck in your guys' careers and futures. Thank you.
Yeah, thank you. It's our pleasure, and good luck.